Very good morning, students. Today we are going to learn how to conduct the experiment number 2, which names half wave and full wave rectifier with and without filter. I repeat, so we are doing electronic devices and instrumentation lab. So experiment number 2, which says half wave and full wave rectifier with and without filter and to measure the ripple factor. Okay. Before I start showing you how to conduct the experiment, I will brief about whatever components we are using for this experiment. So the aim of the experiment is to find out the output of a half wave and full wave rectifier. So we need to measure the ripple factor and with and without the filter. Fine. So what is a rectifier? So rectifier is an electronic device that is going to convert the given input AC into DC. So that means you will be giving AC voltage for your AC to your device and output you will be checking as a DC. So what are all required? So this is called as a DSO, digital signal oscilloscope. So it has got few channels, so it has got few knobs which you would have learnt in the introduction class itself. So I will not spend much time explaining you this again. So I am using only one channel to show the output, that is channel number 1. Okay. So these knobs are used to check the voltages or set the voltages, and these knobs are used to move the waveform horizontally. Alright, and there is a knob called as auto. So when you press this auto, whatever the red the values are there, that means the voltages will be shown directly when we press auto. Fine. If we want to save the waveform, so we can save using this button, and if you want to measure, you can use this button to measure, automatically measures. So actually there are two types of display devices. Remember, this is just a display device. Whatever the output you get from your circuit, this is going to just display. It is not going to add anything to your circuit. You got the point? Just like your monitor, LCD monitor. So CPU is different. CPU is doing all the processing, and the display monitor is just displaying. The same way the DSO here, what you see, is used just to display. Alright, and then I require a decayed resistance box. So this resistance box is acting as a load output across which we need to take the values of the readings. Okay. Then this is a transformer. So which is read as, you can see here, 12012. So that means it has got 3 tappings here. Can you see 3 knobs? So if I connect the blue and the black, it will give me 0 to 12. Always this 0 indicates ground and 12 indicates a positive voltage, and then I have another 12 volts which I will be using for the full wave rectifier. For half wave rectifier, I require only 0 and 12 volts. Okay? So then this is the decayed capacitance box where the capacitor acts as a filter for the given rectified output. Fine. And this is a breadboard. Explanation of the breadboard has already been completed in the introduction class, so I won't spend much time on that as well. And this is a diode. Okay, this is how a diode looks like. So on the diode there will be a grey color marking. Okay, so that indicates the negative terminal of the diode. That means it is the cathode. So the one which is not colored will be the anode. So you need to place the diode as shown in the circuit diagram. The circuit diagram says that, so we have anode and then there is a cathode. Just make a connection in the breadboard like this. Hope you are all understanding. So this is anode and this is cathode. Fine. So if you look at the circuit diagram, positive 12 volts supply from the transformer which acts as an AC is given to the anode of a diode. You getting? So positive 12 volts, I told you this is 12, this is 0 and this is 12 again. So since it is a half wave rectifier, I will be using only 12 and 0. So positive 12 volts is given to the anode of the diode. Look into your circuit. Fine. If you have any doubts, so you just go back to the introduction part where each of the components have been explained. So then you get back, then you will be able to understand what is the connection, how is the connection being made on the breadboard. So we have the diode, anode and cathode. How do I identify? I told you there will be a grey color tape which is being placed on the diode. That grey the grey tape indicates, or the grey coloring indicates it is negative. Okay. So then I give positive here. I make any one of these lines as a common ground, because many points are going, look into your circuit, many points are coming for the ground. So I make this horizontal slab as slots as my common ground. Okay. So after this the supply has been given, then I need to give the resistance, isn't it? So that means the load is connected across the diode, that is negative, and then negative of the diode, and it is given to the common ground. Hope it is visible very clearly. I can give it to any of the terminals here. So I have taken load positive and given to the load negative here. I will maintain 5K. You can see the different readings here. So according to the design, so you need to keep the resistance, the decayed resistance box, it is a variable resistance box. So keep it to 5K, alright. And then in the circuit there is a voltmeter symbol which is ranging from 0 to 20 given. So voltmeter, since you are using a DSO, voltmeter is not necessary because it will only check the output voltage, fine. Then I take the probe from the DSO and connect the positive. Look into the circuit, where is the probe from the CRO or the DSO connected? So the positive is being connected to the negative of the diode, and then the negative is given to the common ground. Hope the things are clear. I give it to the common ground. You can see the output there already coming. Okay. So you can see that the output is already rectified. So the input what we have given from the transformer is a sine wave, but since it is a half wave rectifier, the diode allows only positive half cycle and it will conduct in only forward direction. So negative half cycle is cut off, it is being removed. So that is what you are seeing in the CRO output, DSO output. Okay. So once you press auto button here, okay, you will be able to see the voltage. So that is why voltmeter is not necessary. So if you still want to cross check, so you can connect the voltmeter parallelly across the diode and you will be able to check the peak to peak voltage. So input peak to peak is given to be 12012, that is 24, and the output I am getting it as 17 volts. Is it clear? So the peak, one peak and then the other peak, so it will be 17 volts. Is it clear to all of you? So the peak to peak voltage is going to be 17 volts. You need to note down this, fine. So this is what is your 2 times of Vm, because it is measuring peak to peak. From this peak, negative peak is not there, so it has taken this peak. So Vm is going to be 17.2 volts. Note down this peak to peak value, and then you need to substitute that in the given tabular column. You can look into the tabular column. So we have first in the tabular column, the first reading says VL, Vm. Okay. So VL is going to be the supply voltage, Vm is the maximum voltage, fine. So then it is going to be the VDC, that is Vm by 2, fine. So then Vrms is equal to Vm by so Vrms will be equal to Vm by 2 root 2, like that. So substitute all the values using Vm, and finally you will be able to get the, substitute the values and get the value for ripple factor. Okay. Ripple factor is nothing but the amount of AC component present in a DC waveform. Now actually this is DC, this is supposed to be DC, but still it is called as a pulsating DC because we have the actual sinusoidal look here. Can you see? It is still sinusoidal. So in order to get a better output, getting what is DC, it should not have any frequency, but still I am able to see certain frequencies here. In order to get a better output, so what we can do, we can connect a filter at the output. So once you connect the filter at the output, the waveform goes near to a full wave near to a rectified output, that means near to DC value. So to do that, before that there is a last column in the tabular column, you can see the last column. It says regulation, for percentage of regulation. What you do, so you have the resistance given here, right, this acts as a load. So now you have given the maximum load, okay. So and the reading of the voltage, it is saying it as 17 volts, correct na? So that is for full load. So now what I will do, I will reduce this voltage, make it to very minimum, okay. So say about, since I had given it as 5K, I will give it as 1K, So when I reduce, that we call it as no load. So we cannot have any circuit without any load, but no load means a very minimum load I am giving. When I am giving very minimum load, I am getting the value as 16.8, something like that. Okay. So you can see when I give 5 volts, 5 kilo ohms, I am getting 17.40 volts, okay, peak to peak value. When I reduce it to 1K, I am getting it as somewhere around 16, it is flickering between 16.8 to 17, okay. So that means approximately, it actually ideal case regulation should be 0. So you will not get 0 here, you will get some value which is in 0.07, 0.08 or 0.6, 0.4 like that, okay. So depends on the reading. So this reading is 16.8. Okay, so we got full load as 17.40 and the no load as 16.8. Actually regulation is a modulus, so you can take modulus of no load minus full load divided by full load. Is that clear? So after taking the regulation, keep back as 5K, 5 kilo ohm. Then we need to connect a filter. Filter is nothing but your capacitor. Okay, so the value of the capacitor, we will consider it as 10 microfarad. Okay, so we need to set it here. You can see this is 1 microfarad, 0.1 microfarad, fine. So let us set it to, yeah, maximum it is 9 microfarad, not an issue. So we were supposed to set it to 10 microfarad. So since maximum this is showing 9 microfarad, no problem. So it should be 10 microfarad here. I will connect it parallel to the given half wave rectifier. Why I am doing this? Because the output DC what I have got is a pulsating DC. To convert it into a actual DC, I will connect a filter. So of 10 microfarad. So don't change anything in the circuit, just connect a capacitor parallel to the diode. Parallel to the resistance. Wherever you have connected resistance, no? So the same way connect it parallel like this. When you connect it parallel, you can see here? Okay, this is what is the expected output waveform. You can check with your manuals also, fine. So this is what is the DC. You can see the change in the frequency also, isn't it? So now when I press auto, I am getting the value as, okay, you are getting, so 5.8 volts. So this peak to peak value I am getting 5.5 volts, that means charging and discharging of the capacitor. It is only identifying, what is the capacitor filter doing? It is only identifying the peaks of the given input waveform, okay, and then it is discharging. Fine, it depends upon the time constant RC, nevertheless that is not required here. So now you need to take the peak to peak value as 5.80 and fill the tabular column with filter and find out how much will be the ripple factor. So what is the aim after putting the filter? The ripple factor should be lesser than whatever the ripple factor you would have got without the filter. Is that clear? So and repeat the same thing with the for a no load and full load case. So full load is 5, so I will make it as no load. So now I could hardly see any change, as you can see here, isn't it? So when a capacitor is added, so the load is not having any effect on the output waveform. So that means the percentage regulation is also better. It is approximately equal to 0. Can you see 5.8 only? So the percentage of regulation will be nearly equal to 0. Is it clear? Alright. So now let us see the next experiment. So that is going to be a full wave rectifier. So for the full wave rectifier, just remove the capacitor as of now, because we need to conduct the experiment without the filter, and then with filter. Okay. So look at the circuit diagram. In the circuit diagram, it is very clear that we require 3 types of inputs from the transformer. One is 12 volts, the another is center tapping 0, and the last one is another 12 volts. Correct na? So in your manual it is very clearly given. Okay. So the output from the transformer. So what is this transformer? It is a step down transformer, because the input is given from the supply, which is 230 volts. Okay. So now this input has been step it down to 12 volts. So, whenever you are conducting the experiment, make sure that the transformer is off, okay, and your supply is also off. So, whenever you are making a new connection, all of this have to be off. Make the connection first, show it to the faculty. After getting the confirmation, then only you should turn on the components. So, I have turned off the transformer, I have turned off the CRO. If you have the signal generator used in your experiment, you have to turn off even that. Fine. Okay. So, let me modify in the previous circuit itself. Okay. So, 12 volts is given here and the center tapping is given to, as usual, it is given to a common ground. Look into your circuit, and then another 12 volts is given to, you can take another point, okay, and you can see the negatives of both the diodes are shorted. How do I identify negative? I told you there is a grey color code which has been drawn, grey color a tape has been put here. So, we can say a grey color indicates it is negative. Okay. So, I put it in another terminal, other slot, okay, a vertical slot as I told you. So, the negatives have been shorted, simple, see it is so simple. So, try to use as minimum wires as possible, alright. So, I connect the positive here to one other slot, okay, and the negative has been connected here, the negatives and negatives of both the diodes are shorted. So, I just connect it like this, alright. Then 12 volts is given here. That is all, over. That is the only change I made to get a full wave rectifier. I have added two different diodes. One is going to conduct during the positive half cycle, another is going to conduct during the negative half cycle. So, what is the change that I did? So, I gave the other 12 volt supply for this diode and shorted the negatives of these two diodes. That is all. That is how it looks like in your circuit diagram as well. Okay. After that, turn on the transformer and turn on your signal generator. So, yeah, see, we will be able to see a full wave rippled DC. Okay. So, why it is rippled? Because we are able to still see the sine wave here. So, we should try to reduce this. So, we should be able to get perfect, try to get with the less frequency, we should try to get a straight line like a DC. Practically getting direct DC from AC is not possible. So, we will do it using a filter nevertheless. So, what are the takeaways from the full wave rectifier after getting this output? Okay. So, this is the expected waveform. Okay. You will be, let me try to save this, save it as a waveform. Okay. Fine. I have saved this full wave rectifier. Alright. So, then I will press auto to take the measurements of the peak to peak voltage. Yes. Okay. It gives me 17.4 obviously. So, why? Because we have the output present for both the positive and the negative half cycles, alright. So, one peak is going to be 17.4, alright. So, then we will you take down that readings. After taking down that reading, the mean value also it will show 10.40. Then we need to put the filter. Yeah, before that we need to measure the full load and the full load and the no load measurements for percentage regulation. Okay. So, for that it is full load, it is already 17.4. I will take it for no load, that means minimum load. So, when I reduce the load here, make it very less, I am getting it as 16.8 or 17, same as that of what I got it for half wave rectifier. Alright. So, now what is the next thing that I have to do? I have to, got it, no? So, first take it for full load, okay. So, repeat the same thing whatever you did for the half wave rectifier. Uske baad mein you just change it to no load. So, there you can see it is approximately 6 point, flickering between 6.8 and 17, 16.8 and 17 volts. So, nevertheless, so it will be approximately nearing to 0 or some point values you will get. So, then we need to see that the ripple factor will be reduced. So, in order to reduce the ripple factor, ripple is nothing but the amount of AC present in the DC output. So, I will take a capacitor as usual. So, a capacitor as a filter, how should I connect it? How did I connect in the half wave rectifier? I had connected in parallel with the load. Okay. So, load matlab whatever the decayed resistance box I had connected, the same way I should connect the capacitor filter also. So, can you see here the same 10 microfarad. So, since I could not make it to 10, okay, the 9 is maximum what we can have here. So, 9 microfarad is taken, but in the design you need to write it as 10 microfarad, and the positive has to be, that means it has to be connected in parallel with the load. So, I take the positive here and I take the negative and give it to the common ground. You can see. Can you see there? Yes. So, let me stop this. Yeah. So, this is what you get, which is nearing to DC. That means it is the capacitor is just clipping off the peaks of the AC output waveform. So, the rippled DC waveform we can say. So, and it is giving it is nearer to a straight line. It is far better than whatever we were getting without the filter, isn't it? So, with the filter, what are the takeaways? So, you need to first measure what is peak to peak voltage, which is already showing you as 3.4 volts. Okay. After measuring peak to peak voltage, then you need to note down what is the no load and the full load, isn't it? So, full load is nothing but the same thing 3.4, and the no load, as we can see there are no changes at all. So, that the percentage regulation will be exactly 0. Is that clear? Okay. Any doubts, students? If you have, you can just put it in the reply comment box. Okay. We will try to answer that, or you can ping us individually. So, we will let you know how to take the readings as well. Okay. First of all, as I told you, main thing we need to measure is the peak to peak voltage and the no load and the full load voltages. So, using that only we will be able to calculate what is the ripple factor, we will be able to calculate what is the percentage of regulation, okay, and efficiency also. So, we will be able to find out what is the efficiency of a half wave rectifier and the efficiency of a full wave rectifier as well. Okay. This is all about a half wave and a full wave rectifier with and without capacitive filter. Thank you.